Alright, scholars, all I gotta say is don't try to creep. We're rolling on to the last problem. Here we go. That's right, dudes. Awesome. Problem number 7 here. We're going to find the specific term now in our awesome expansion. So we're going to find the sixth term of our binomial a plus 2b to the power of 7. And we're going to be using the awesome, gnarly gangster binomial theorem. Okay, don't start screaming yet. This is going to be okay here. So I just wrote down right here, and that's going to be our sum of n choose r, where we take our first term. All we're going to do is just subtract n minus r, and then y to the power of r. So watch how quickly we can find the sixth term without having to expand the whole thing down and then having to choose our sixth term right here. So let's go ahead and first choose our n and our r. So our n is always going to be this number right here, 7. And what about our r? Well, let's just think about this intuitively real quick. We know that our first term, r always begins with 0. And then r would be 1, r would be 2. So whatever term that they're asking for, they're always going to go one less. And so if you wanted to count this, this would be our first term, second term, third term, fourth term, fifth term, sixth term. Well, look, r is 0, 1, 2, 3, 4, 5. So the whole goal here is that whatever r that you're going to choose right here, it's always going to be one less than whatever term that you're finding. It's going to give us our sixth term, but the way that you find r is you just do one less. So we're going to go ahead and choose 5 right there. Now that we know what n and r values are, so now all we're going to do is this. Find our x term, which in this case is just a. So right here. So that's going to be my first term. And then just do n minus r. Over here. 7 minus 5. Oh, that's pretty chill right there. And then we take our y term, or in this case it's 2b, the whole entire case 2b, and I just raise that to r. Well, r is 5. And this is it right here. This would be the sixth term, but if you leave it like that, you're only going to get like half credit, right? Because you didn't go and clean it up right there. So our calculator will calculate 7 choose 5. So let me just do that real quick. Press 7, math, scroll over to probability, choose option 3. So that right here alone just gives us 21. A to the 7 minus 5 is going to give us a squared. And then 2 to the 5th, let's see, it's 2, 4, 8, 16, 32. So times that by 32, b to the power of 5. So I raise 2 to the power of 5 is 32. B to the power of 5 is b to the power of 5. And then we're just going to multiply these two guys, and then we're done. So 21 and 32. Oh, all right. So that whole thing becomes 672. A squared and b to the power of 5. Super chill, super rad. All right, now come over here now. We're going to now find the third term, to the power of 12. Imagine trying to do that whole big old Pascal's triangle. So we're going to use our binomial theorem again. So I'm just going to go and write it real quick. X to the n minus r, y to the power of r. So let's see here. Let's go and choose our n. Come over here, 12. And our r. Remember, our r is 1 less than whatever term that they're asking. So we're going to choose 2 as our r. And then we find our first term, x. So in this case, our first term is 3x. So we're going to multiply that by 3x to the power of n minus r. So 12 minus 2. All right, right here, we're going to get a pretty big number here. I can already see already. And then we take our y term, which is our last term. Little trickery right here. Our y term is the entire, even with the negative. Because how do you know if it's going to be positive or negative? Well, you can always get it by including whatever this sign is. So it's going to be negative 4y. Okay, negative 4y is going to be our y, right here, to the power of r. R, 2. All right, so let's go right here. So we'll do our 12, choose 2. And let's see here. And syntax there, that's nice. So there, 66. So we have 66. Okay, so that's what this became. 3 to the power of 10. Oh, tamale. Big old thing right here. So multiply this by 59,049. And then don't forget to also raise that x to the power of 10. So this whole thing all just simplified to this. And then we need to do negative 4 to the power of 2, which is going to be 16y squared. So, woo, Glad we didn't use Pascal for this little guy right here. So let's go ahead and multiply this all out. So 59,049 times that by 16, multiply that by 66. Oh, we up in the millions, the millies. Here we go. So let's see, 6, see, 2, 3, 5, 5, 7, 4, 4, 1, 2, 3, 1, 2, 3, oh, 62 million. Woo, here we go. X to the power of 10, and then y to the power of 2. So very, very helpful to use just this binomial to find a specific number, especially when you're moving into numbers that are bigger than 10. Later.